Hi class, Dr. Selby again here, and I wanted to go through one more example of how to label bonds when you're given an organic ionic compound. In the last video example, it was an organic molecule, so this is a little bit different. I will go faster through some of the steps, but if you watch the previous video, that should help you fill in the gaps with these steps. So let's get started. The first step is to turn this line bond structure into a condensed structure. And to do that, all we're going to do is label endpoints and vertices with carbon atoms and then add in missing hydrogens. So we have an endpoint here, that's a carbon, and a vertex, that's a carbon. And then to get the number of hydrogen atoms, we're just going to count to 4. So on that leftmost carbon, we only have one bond, and carbon needs 4 bonds, so we add in 3 hydrogens. And then in that middle carbon, we have a double bond, which counts as 2, and then 2 single bonds, so that already has 4. So this would be the condensed structural formula. The next step is to turn this into a Lewis structure. So in Lewis structures, we're going to show all bonds and all lone pairs. So this middle carbon here is double bonded to oxygen. And when oxygen has 2 bonds, it's going to have 2 lone pair. That middle carbon's bonded to that left carbon. This one here. And that carbon is bonded to 3 hydrogen atoms. And we're also bonded to, that middle carbon's bonded to an oxygen. It's a covalent bond. And it has a negative charge. And if an oxygen atom only has 1 bond and a negative charge, then it's going to have 3 lone pair. Now you might recognize that this can have a resonance structure, so we could have flipped these 2 oxygens, but we'll just stick with one resonance structure. The point is that negative charge is localized on one of those oxygen atoms, and from symmetry, it does not change the structure. And then we'll just go ahead and add in our sodium ion and show the charge. Next step is just to list all bonds. And here we have 3 carbon to hydrogen bonds. I'm only going to list them once because they're the same. We're going to list unique bonds only. Then here I have a carbon to carbon. Here I have a carbon double bonded to oxygen. Here I have a carbon bonded to oxygen. And last but not least is this ionic bond, an O- to Na+. The next step is to calculate electronegativity differences in those bonds, and you need some reference information. This is taken from your textbook. And I'm showing here carbon. So here's the value for carbon. And I'm showing here oxygen. And here's the value for oxygen. And I'm just taking the difference. And the absolute value of the difference. And so I'm just going to go ahead using that technique for the rest of them to fill in those values. And so here's all the electronegativity differences. The last step is just to label the bonds using those electronegativity values. And you need some source of information for what electronegativity difference is labeled as what bond type. And so we just match these values with somewhere in here to label the bond type. And so I've done the first one. We have electronegativity difference of 1.0, and that falls in this range, and so it's labeled polar covalent. And we can continue on in the same method to get the rest of the labels. And here they are. This is the end of the video. I hope this was helpful. If you have any questions, please send me an email. Thank you. Have a great day.